Hello there, welcome to my introduction on neutron stars. In this video we'll discuss how these stars are made, what they are, and some interesting facts about them. So let's first start with the formation of a neutron star. Neutron stars form out of the cores of high solar mass stars of about 10 to 30 solar masses. During the life of any star though, there is a balance between outward pressure wanting to make the star expand, and inward gravity wanting to compress the star. However, when in the final stages of a high solar mass star's life, when the core is entirely inert iron, there is no longer any energy production, and thus outward pressure completely turns off. As such, gravity applies immense compressive force on the core of the star, causing the core to shrink in size until a point where the atomic neutrons could not possibly get any closer together. An exerted force called neutron degeneracy pressure, which altogether stops the further shrinking of the core. What finally remains is an incredibly hot and dense core with a radius of about 10 kilometers and a mass of about 2 solar masses. However, they're not very luminous. This means they're heavier than the Sun, but about the size of Toronto. As well, if you were to only measure 1 cubic centimeter of a neutron star, you would find it to weigh about as much as Mount Everest. Now, how would you even find these stars in the first place if they're so small and so dim? Wouldn't that make them incredibly hard to find? Well, let's look into that next. Now, it is true that these stars would be very hard to find in theory. However, a neutron star orientated in a certain way will emit radio waves out of its magnetic poles, which could point directly at the Earth. Meaning every rotation of the star would send a beam of radio waves right towards us. As such, if you were to point a radio telescope at a patch of the sky, the chances are you could be pointing directly at a neutron star, and then you would detect the pulsating radio waves from that star. These pulsations are incredibly consistent and make for the most accurate clocks in the universe, by measuring the length between each pulsation. These pulsating neutron stars are very aptly named pulsars, and listening to some of the radio waves produced is very interesting. Let's take a listen to some to conclude this introduction.